In this session, I would like to share about tree data structure. Tree is a nonlinear data structure that does not store data in a linear way. Linear way refers to the sequential way. Tree data structure organize the data in a hierarchical manner. Here, these are the example of hierarchical structure, which means a parent, child, subchild, and so on. These are the example of the hierarchical structure. In tree, the tree is a collection of nodes and edges. Nodes are used to store the actual data, and it also provides the links to the next element. And edges are used to connect more than two nodes. There are some basic terminology for tree data structure. The first one is root. Root is called the first and topmost node is called the root node. Every tree must have only one root node. We never have multiple root nodes in the tree. For example, A is the topmost node, so it is called the root node. Next, node and edges. Nodes are used to store the actual data and it provides the link to the next element. Node are represented by the circle. Then edges act as a communicating link between more than two nodes. If there is a n number of nodes, there must be n minus 1 number of edges. Here there are 11 nodes, so we should have 10 edges. So n is equal to 11, then n minus 1 is equal to 11 minus 1, that is 10. Here the nodes are represented by the circle and edges are represented by the line or arrow. Next, parent node. Parent node is a predecessor of any node. In other term, every node which has a child, it is called parent node. Here A has a child B and C, B has a child E, C has a child G. So A, B, C, E, G are parent nodes because the nodes which has a child. But H, K, F, J, I, D which does not have a child, so this is not a parent node. Next, child node. Child node is a successor of any node. Any parent node can have any number of children. There is no limitations. Next, in a simple term, the node which has a link from its parent node is called child node. Here, B and C are the child node of A. D, E, F is a child node of B. G and H is a child node of C. K is a child node of G. In tree data structure, all the nodes except the root node is called a child node because root node does not have parents. It is the topmost node in the tree. Next terminology is siblings. Node which belongs to the same parent are called siblings, which means nodes with the same parent is called siblings. Here B and C are siblings because it belongs to the parent A. Then D, E, F are siblings because it belongs to the parent A. The node which has the same parents is called siblings. Next, a leaf node. Leaf node means which node does not have a child is called a leaf node, which means a node with no children is called a leaf node. Leaf node is also referred to as external node or terminal node. Here, it is also represented by the bottommost node. Root is called the topmost node. Then leaf node is called the bottommost node. Here D, I, J, F, K, H are referred to the leaf node because they does not have any child. Next, internal node. Internal node is also called non-terminal node, but leaf node is called the terminal node. Internal node is called the non-terminal node. Internal node is refers to the then which node has at least one children is called internal node. Here root node is always called as internal node. Here A has 2 child, B has 3 child, C has 2 child. So these are the internal node. Here degree is referred to as the total number of children. Here A has 2 children, so degree of A is 2. B has 3 children, so degree of B is 3. C has 2 children, so degree of C is 2. E has 2 children, so degree of E is 2. F has 0 children, so degree of F is 0. Then levels are referred to as each step from top to bottom. The level count starts at 0 and incremented 1 by 1. The root node is said to be at level 1 and child of the root node are said to be the level 1. Next, the child node of the particular node is called level 2. The levels are incremented one by one. Root node is level 0. Next node is child is level 1. Next subchilds are level 2 and so on. Next, height and depth. Height are referred to as the total number of edges from the leaf node to the particular node, which is the bottom to top. We can calculate the height from bottom to top. So first is height 0, next height 1, height 2, height 3. The total number, we have to calculate the total number of edges, not a node. It is the calculation of edges from the leaf node to the root node. But depth is the reverse process of height. We can calculate the depth from root to leaf node. The height of the tree is 3. So 1, 2, 3. Here depth is calculated from the root to the particular node. So 1, 2, 3. Next, path is referred to as a sequence of nodes and edges. For example, if I want to traverse from A to J, the available path is A to B, B to E and E to J. So the sequence of nodes and edges are refers to as the path. Next is subtree. Each child forms a node that forms a subtree. Each child node can act as a parent in a subtree. Here, these are the tree. We can form a subtree means we can form a small tree, small part of a tree. Here A, I, J is also called a subtree. B, D, E, F, I, J is a subtree. G, C, G, H, K is a subtree. We can also create C, G, H is also a subtree. But subtree consists of a one parent node and more than one child node. Thank you.